A Ukrainian drone team recently faced a U.S. armored brigade in a military exercise. According to a new report, the Ukrainians found and eliminated American vehicles so quickly that some had to be brought back into the game or respawned just to keep the exercise running. But no real brigade was destroyed, no tanks were blown apart. And the lesson is not that a toy quadcopter can automatically defeat the U.S. Army. The real lesson is more interesting. Small drones have compressed the time between being seen and being attacked. On a battlefield where observation is nearly constant, even heavily armored forces can become vulnerable before they know they have been found. The exercise was Combined Resolve 2607, held in Bavaria, Germany, during April and May 2026. Combined Resolve is designed to prepare an American armored brigade for large-scale ground combat alongside allies and partner nations. Around 3,500 American personnel participated, mainly from the 3rd Armored Brigade Combat Team of the 1st Cavalry Division. Their mission included attacking positions held by the training center's professional opposing force. That defending force was reinforced by Ukrainian operators from the 412th Nemesis Unmanned Systems Unit, one of Ukraine's most experienced drone formations. The Ukrainians first used reconnaissance drones to locate American troops and vehicles. According to the Wall Street Journal, the heavy vehicles created visible clouds of dust as they moved. Once spotted, they were approached by drones representing bomb-dropping aircraft and first-person view attack drones. In real combat, an FPV drone carries an explosive payload and is manually flown into its target. During this exercise, the drones generally did not carry live explosives. A drone could hover above a vehicle or approach closely enough for an observer to declare a simulated kill. So, when reports say the brigade was destroyed, they mean that the exercise's referees judged enough American forces to have been eliminated under the rules of the simulation. The vehicles were still physically fine. Some were returned to play as fresh units because the Ukrainians were scoring kills faster than the scenario could continue normally. That distinction matters. An exercise cannot perfectly reproduce artillery, air power, casualties, logistics, fear, weather, or the confusion of real combat. The Americans were also attacking a prepared opposing force reinforced by operators with years of current battlefield experience. Training centers are supposed to create unfair and uncomfortable problems. Losing there can prevent people from dying later. Still, the result exposed a real mechanism that is reshaping warfare. Think of the drone operation as a 3-part chain. First, something searches. Then information moves to the people making the decision. Finally, something attacks. That chain existed long before small drones. A scout might locate a tank column, report it over a radio, send coordinates through headquarters, and wait for artillery or aircraft. Each handoff took time. The target could move, hide, or strike first. Small drone teams shrink that process. A reconnaissance drone provides a live view. The operator can pass the target's location to a nearby bomber drone, an FPV team, a mortar crew, or another weapon. In some cases, the sensor and the weapon are effectively part of the same small unit. The strange part is that the reconnaissance drone may be more important than the drone making the final attack. It turns ordinary movement into usable targeting information. Dust, engine heat, radio transmissions, fresh tracks, and vehicles entering tree lines can all help reveal where a unit is going. If you enjoy explanations that look past the headline and show how the technology actually works, subscribe. There are going to be plenty more stories like this, and the mechanism is usually more important than the gadget. The U.S. Brigade was not simply sent into the exercise without drones. Official Army reporting says the formation was employing more than 400 unmanned aircraft across 6 commands. It was also testing sensor fusion, electronic warfare, distributed communications, and systems intended to speed up decisions. That makes the result more revealing. This was not a case of one side discovering drones while the other side had never heard of them. The difference appears to have been how quickly and naturally the tools were integrated into battlefield behavior. Ukraine's advantage came from experience. A successful drone formation is not just a box of aircraft and a few talented pilots. It is also reconnaissance, target analysis, radio knowledge, maintenance, ammunition handling, communications, concealment, and constant experimentation. If a drone fails, the team studies why. If jamming blocks one setup, operators test another. If a component breaks, technicians repair or replace it. Lessons can move from one flight to the next instead of waiting for a new vehicle program years later. This helps explain why standard electronic warfare and counter-drone systems did not automatically protect the American vehicles. A jammer is often imagined as an invisible force field. Turn it on, and every drone falls out of the sky. Real electronic warfare is much messier. The defender has to detect the drone, understand what signal it is using, place enough energy on the correct part of the spectrum, and maintain useful coverage. Terrain, buildings, trees, distance, and the position of antennas all affect performance. Strong jamming can also interfere with friendly friendly radios, navigation, and drones. Meanwhile, the attacker can change flight paths, control methods, frequencies, launch positions, or the timing of an attack. Even when jamming works, it only solves one part of the problem. The reconnaissance drone may already have reported what it saw. The defender also faces a difficult numbers game. A counter-drone system must watch the sky while the unit moves, detect small objects, decide which ones are hostile, and stop enough of them to keep the formation operating. The attacker only needs a few drones to slip through or observe from the edge of the defended area. Armor adds another complication. Tanks and fighting vehicles are built to combine protection, firepower, and movement, but they are large, noisy, hot, and difficult to conceal, especially when several move together. Their strength depends on concentration and momentum. Drones punish both by making concentrated movement easier to detect. This does not mean tanks are obsolete. It means armor can no longer behave as though controlling the ground also means controlling the air directly above it. The exercise's second phase is therefore just as important as the initial defeat. The Americans reran the scenario during the 2-week engagement. They improved by spreading vehicles farther apart, using concealment more carefully, and employing electronic warfare more effectively. Dispersion changes the attacker's calculation. If 10 vehicles are parked tightly together, one reconnaissance flight can find an extremely valuable target. If those vehicles are separated, hidden, and moving along different routes, the drone team has to search more territory and conduct more attacks. Concealment is no longer just camouflage paint. It means controlling dust, heat, movement, radio emissions, tracks, lighting, and the shape of positions when seen from above. A tree line that hides a vehicle from someone on the ground may do very little against a camera looking almost straight down. The Ukrainians later switched sides and helped the American force employ drones offensively. According to the report, the Americans then used the technology effectively. That is exactly what a useful war game should produce. It identifies a failure, lets the unit change its behavior, and tests the new approach while the consequences are simulated. The U.S. Army is already responding more broadly. It has updated doctrine around constant observation and is experimenting with formations that combine scouts, electronic warfare, FPV drones, loitering munitions, mortars, and armored vehicles. In another Army test, a multifunctional strike troop used drones to locate jammers and command posts, disrupt defenses, and create openings for tanks and infantry. The goal is not to replace every armored vehicle with a quadcopter. It is to connect unmanned sensors and weapons to maneuver forces so each covers the other's weaknesses. Could a counter-drone bubble eventually give armored units freedom to maneuver again? Probably for limited periods and in limited areas, but not as a perfect shield. A serious defensive bubble needs layers. Radio frequency sensors can listen for control links. Radar, cameras, acoustic sensors, and infrared systems can search for aircraft that do not reveal useful signals. Jammers can attempt to break control links. Guns, interceptor drones, missiles, lasers, or other systems can handle targets that continue flying. Those layers can make drone attacks slower, harder, and more expensive. They may create a temporary corridor in which armored forces can concentrate and move. But the bubble itself becomes a system that must move, communicate, carry ammunition, and avoid being detected. It can also be targeted. This creates a continuing contest. Drone teams change their aircraft and tactics. Defenders update sensors and countermeasures. Attackers search for gaps. Defenders add another layer. Neither side receives a permanent technological victory. The biggest misunderstanding, then, is that Ukrainian drones defeated American tanks. What actually defeated the simulated brigade was an experienced reconnaissance-to-strike system operated by people who had learned to adapt at battlefield speed. The warning for conventional armies is not that expensive platforms suddenly have no value. It is that those platforms now operate inside a much larger network of cheap sensors. Survival depends on hiding better, spreading out, repairing quickly, controlling electronic signatures, and making decisions before the other side completes its own detect-to-strike chain. Combined resolve did not prove how a real war between major powers would end. It did show how quickly a familiar armored formation can lose its advantage when another force sees first, communicates faster, and attacks from above. And because the Americans adapted during the exercise, the story is not simply about defeat. It is about how militaries learn before the lesson becomes real. What part of drone warfare should we break down next? Leave your questions and topic suggestions in the comments.